Okay, in this session, we're evaluating convective cells for lightning potential using our empirical rules. Empirical rule number one is ecotops reaching to minus 20 Celsius altitude. And the second empirical rule is a convective core of 40 dBZs reaching to minus 10. So that's our definitive lightning uh, presence indicator is that second empirical rule. So the first one gets us focused on the cells that need to be met watched, and then we're going to use GR2 analysts or cut the 2D cross sections or our 3D volume sections over the cell and see if we can find out if we got a convective core of at least 40 dBZs reaching minus 10 altitude. The setup we got here is we're going to be watching Elkhart, Kansas. We're going to simulate that there are a Met Watch location we need to put a lightning watch out for, and we're going to see if these cells back to the southwest. We're using Amarillo's radar. See if these cells back to the southwest are going to hold together and give us some lightning at Elkhart. So current Zulu time is 15:09. As back far as we can go on GR2 right now is 14:26. So about 45 minutes prior, we can take a look at this cell. It did have a history of several pretty active rows of lightning along that band there. And the most recent one, though, is fairly old. That would have been 1403, so over an hour old, but we still got good ecotops in there. All right, so our first empirical rule is ecotops reaching to minus 20. So we've got cells with ecotops of, well, 26, 27, 28,000 feet. So 26 to 28,000 feet. We go to our algorithms tab at the top and select environment settings. We'll see that there is a sounding in there. And this is a RUC sounding from 14Z, so it's about an hour old, but that's still good, pretty fresh data. And we get a 0 degree altitude or the freezing level and the minus 20. This is for use by GR2 for the hail detection algorithm that it uses. But we're going to use it for lightning. We're going to be chasing lightning using these values. And the first one is that 20,000 foot, roughly, well, 20,000 foot minus 20 degree altitude. So our ecotops have definitely gotten beyond that. So that's our first filter is, do our cells have 18.5 dBZs or ecotops up past minus 20? And the answer is yes. Next thing we want to look for is our 40 dBZ core, convective core reaching minus 10. So this doesn't feed us to minus 10. We got to kind of do a little calculating here on the fly. Our freezing level is at 12,000. Our minus 20 is at 20, so that's an 8,000 foot difference. So split the difference, about 16,000 foot on the minus 10 is what we're going to use. It'll get you close enough. All right, so we're back in time there. We cut our cross section through there, and it looks like we can probably hit most of this with one section and then just kind of slide it around. There we go. We're pretty far out from the radar. We're about 100 miles out, so we're pretty high off the deck. So our minus 10 at some point there is not even, we can't even sample it. So about 2/3 of the way though, we can start to see we've got a convective core there. See what our altitude is on that. It does look like it's up above the minus 10, but it's only about 36 dBz. So we do have some 40 in there. So it was still pretty potent at that time. So let's go ahead and step it forward a couple of frames. And well, one of the other things we have to do, I haven't done yet, I should have done immediately, is set our storm motion. So we can find a spot in the storm that looks like it'll hold together, stay coherent for a couple of frames. I'm going to place a marker there. We'll be watching this leading edge right here of our ecotops, that 20,000 foot demarcation spot there. That does look like it holds together pretty well. Place my storm motion for marker. I get 225 at 28. And you can see it did affect how the tops are presented there as well. So a couple frames forward, let's run our storm track. And this says about 45 minutes out on the leading edge there, so we need to be watching this pretty closely and to get our desired lead time of 30 minutes. And let me zoom in just a notch or two here. There we go. And now we're going to use the 3D volume section and select my volumetric mode. And we want to start about in the middle of the cell and draw our box outwards. So we're just kind of mostly concerned with this part. Looks like the other part of the cell is going to kind of miss Elkhart. So we're still well above the deck there with our below beam effect. So all this is unsamplable air, lowest cuts. Only able to see this right here. All right, so let's go ahead and get our alpha table back up and set our filter. We're in ISO surface mode. So we're using a little slider triangle down here at the bottom. We'll bump it up to about 40 dBz, and pretty much everything is gone. I didn't make it to 40 dBz and everything's gone. So right now we're pretty weak. We've got some good convective cells in there, convective cores, but the values are well below what we need to see for lightning. So more than 10, 10 dBzs or close to 10 dBz is probably not enough. If we're a couple, 2, 3, or 5 dBz low, I would not discard it. I would still consider that a pretty good return. However, we're just not there yet. So let's go ahead and step it forward a couple of frames, see how we're doing. Echo tops are still holding up. I mean, they're above 20,000 feet. They've lowered quite a bit, several thousand feet, but we still have 25,000 foot tops in there. Let me go ahead and shoot another volumetric section there, volume section. And we sure don't have values there. There's 35 and there's nothing showing up. So right now, lightning threat is minimal. See, we can still time it in, storm track it. So it's about 30 minutes out. So if anything changes in the next couple of frames, it doesn't look like it. Still holding together the echo tops there, but this could be the case where just if you only looked at echo tops, you might be subjecting yourself to a false alarm by not interrogating a little bit further and getting that cross section. Here's the 2D cross section through there, and you can see it's all pretty weak. 30 dBzs or less. Our minus 10 would be up here at about, whoops, right here, about 16,000 feet. We're running in the 30 dBz range. We're getting closer. Echo top's still holding together. Be a little bit too late now to get our desired lead time at this point, but I think we're okay. We're still in the safe zone there. All 30 dBzs or so is our max. So no lightning showing up. And I've got the blitz lightning turned on, place file, so any strikes would show up there. Here's our most current frame right on the doorstep there. Let's do a 3D volume section this time. And our current time is 15:15. Now that's for the echo tops. Now that should be the last complete volume scan. The cross section and the volume section need the last complete volume scan. So 15:10 is as good as it gets, but you can see there we dropped the filter off at, I believe, 35, and there's nothing there. 36, 37. There's about 30. So well below the lightning threshold. I'd be confident in not having a lightning watch out for this cell. So echo tops might have launched you into a false alarm if you didn't do your due diligence on the cross section and the volume section there. So not quite getting it. I mean, we've got convective core in there. It's just too weak. So good heavy rain showers for Elkhart, but no thunder. They are reporting thunder. Dry thunderstorm. That's to be considered. Now, blitz lightning does pick up on cloud to cloud and cloud to air, but we're not seeing any strikes showing up in the local vicinity. So not quite sure if they're hearing something off to the northwest. That's pretty far out. That's 50 miles away. So they may be picking up some thunder out of these cells back there in Colorado. It's possible. But right now they're safe from this producing any lightning at this point.